we just compare the graphical representation, one used to compare them either in terms of the angle difference between them, which is called phase difference, or in terms of the distance travelled by the wave, that in terms of wavelength lambda, which is called as path difference. So, either in terms of phase difference or in terms of path difference, we now can represent the difference between the graphs as such. So, let us start this way. What is the phase difference? That is what we want first. Phase difference. Phase difference between displacement and velocity, how much? Velocity and acceleration, how much? Similarly, displacement and acceleration, how much it is? So, we now can write phase difference, first one, between displacement and velocity. That is, how much is the question? It is now pi by 2 radian. What for we can take like that? You just look at, this is starting from the origin, whereas this graph is starting from the maximum. That means when time is taken as 0, already velocity is ahead by what? 1/4 a wave, which of course can be taken as pi by 2 radian as such. And what would be the second one, that is displacement and velocity we have taken. What is between velocity and acceleration? Velocity and acceleration. What is the phase difference between these two? Even here also you will be finding the same value, that as pi by 2 radian. When we consider the third one, between displacement and acceleration, first one and the third one, displacement and acceleration, what would be the phase difference between them? It will definitely be pi radian. But one thing you should understand in this particular description, velocity is ahead of displacement by pi by 2 radian. Acceleration is ahead of velocity by pi by 2 radian. Acceleration is ahead of displacement by pi radian as such. This is what we call it as phase difference. When we consider the second one, that in terms of wavelength, when I tell the difference like that, that is called path difference. Path difference, of course, of any wave, we used to take in terms of its wavelength. That is actually the distance gap between them, or distance difference between those two as such. That is what we just want. So, path difference when I consider, once again we can say path difference between, we can now say path difference between displacement and velocity. How much it is? That is the first question. You can directly understand the difference between these two graphical representations, if you look at, is 1/4 a wave. So, we directly can write the same as lambda by 4. So, what is the path difference between displacement and velocity? That is lambda by 4. Similarly, the second one, between velocity and acceleration. Velocity and acceleration. If you take, this also is going to be lambda by 4. Because even between the second graph and third graph also, the gap is going to be 1/4 a wave. And coming to the third one, that is between displacement and acceleration. Displacement and acceleration, this now becomes lambda by 2. So, between the first and third graphs, half a wave you are going to find as the difference. So, we can say what is the phase difference between these graphs, what we have plotted there for displacement, velocity and acceleration, and what are the corresponding path differences between them. The moment you have got these things, what is now the relation between phase difference and path difference? Phase difference, what we have written in terms of angle here, and path difference we have written in terms of wavelength lambda here, but what makes the relation between these two? In fact, we can understand well, one complete wave means the total angle in that wave will be 2 pi radian. One complete wave means its length is to be considered as wavelength lambda. That means what is the relation between these two? 2 pi radians that corresponds to wavelength lambda. When once you take the relationship like that, you can obtain a relation in terms of a formula like this. So, let us take the relation between phase difference and path difference. Let us write that one. Relation between phase difference and path difference. Just now I have reminded you, when we consider a wave, total angle what we can observe in one complete wave will be 2 pi radian, and the corresponding length in terms of wavelength we used to consider that one as lambda. So, what we can understand, for a path difference of lambda, the corresponding phase difference will be 2 pi radian. For a path difference of lambda, corresponding phase difference will be 2 pi radian. For a path difference of x, what would be the corresponding phase difference? What will be the value now? You can say 2 pi by lambda into x, that we represent it by phi. So, what is this phi now to be called? It is phase difference is equal to 2 pi by lambda into path difference. That is actually the relation between phase difference and path difference. So, phi is equal to 2 pi by lambda into x. From this equation, one can even understand what is the ratio of phase difference to path difference. Phase difference by path difference, which is the ratio, is equal to 2 pi by lambda. That is what we have to understand out of it. What is lambda there? It is called wavelength of that wave considered. So, when we consider this relationship, where we apply this? Whenever we used to represent progressive waves, particularly we all know well, in the case of a wave motion, we used to find two types of waves by nature. One wave, of course, used to progress like that till it loses its entire energy to the nearby particles. And of course, that dies after some time. You cannot find once again the wave again. Whereas, there are certain waves which are confined to major boundaries. The wave always used to be observed in between those two boundaries only. Such kind of a wave, we call it as a stationary or a standing wave. Anyhow, we are going to discuss about standing waves a little later. The point here we have to understand is where we consider this relationship. This relation generally we used to consider when we write progressive wave equation. When we take progressive wave equation, for its displacement, we can write it this way: y is equal to a sin omega t plus or minus phi. This is the way we people used to write that equation. What is this equation? You just look at once again. A stands for amplitude, sine is the function, omega t is no doubt the angle, that is a phase. What is this phi now to be called? It is called phase difference. You can even call the same as initial phase also. When you put t as 0, whatever that is remaining inside the brackets, that is what we call it as initial phase. So, when t is 0, automatically phi will be the total value remaining. That is what also is called as initial phase. So, when you write this equation, this is what we call it as a progressive wave equation, that anyhow we are going to come across in the case of second half of this chapter, which of course is taken as waves.